This question involves liquid glycerin. It enters at 20 degrees Celsius, so Ti is 20. It leaves at 40 degrees Celsius, so Te is 40. We know the mass flow rate. We want to find Ts. So at this point, which question comes to your mind? Ts is constant. We have two temperatures. We want the third one. Yes, this is the equation. And for this case, we know Ti and Te. We want to find Ts. So let's write out Ts. So in this equation, at which temperature we should evaluate Cp? Yes, we should evaluate Cp at the bulk mean temperature, which is the average between the entrance temperature and the exit temperature. Then from table A-13, we can find Cp. What is As in the equation? If you pay attention to the derivation of this equation, you're going to find this As is associated with convection. If you look at this, As is together with H. So As is the area of the surface which is exposed to convection. So As is pi dl. And in this equation, mass flow rate is known, Ti and Te is known. The only unknown is H. So we need to find the convection coefficient between the liquid glycerin and the surface. Apparently, this is internal convection. So to find the appropriate correlation, we need to determine if it's laminar flow or turbulent flow. We need to find it's hydrodynamically developed or not. It's thermally developed or not. First, let's decide it's laminar or turbulent by computing Reynolds number. In this question, mass flow rate is provided, velocity is not provided. Do you know the relation between Reynolds number and mass flow rate? So we know Reynolds number is rho v d over mu. Here, this mu is dynamic viscosity. What's the relation between mass flow rate and velocity? Yes, mass flow rate, we know is density multiplied by volumetric flow rate. Volumetric flow rate is velocity multiplied by cross-sectional area. So from here, density multiplied by velocity is 4 times of mass flow rate divided by pi d squared. So this is rho v. And there's another d, there's another dynamic viscosity. D and d cancels out. So this is 4m divided by pi d mu. Now let's plug in numbers. You know mass flow rate is provided, so we compute Reynolds number. We find out it is smaller than 2300, so we know this is laminar flow. By the way, in this equation, this mu should also be evaluated at 30 degrees Celsius, which is the bulk mean temperature. And we can find the value from table A-13. So now we have decided it's laminar flow. Then we need to decide it's hydrodynamically developed or developing. It's thermally developed or developing. So now we need to compute the hydrodynamic entry length and the thermal entry length. First, the hydrodynamic entry length. Since it's laminar flow, we should use this equation. The length of the tube is 10 meters. So apparently, the hydrodynamic entry length is smaller than the length of the plate. This means by the end of the plate, the flow is hydrodynamically developed already. Then let's compute the thermal entry length. Plug in numbers, we find is 273 meters. This is larger than 10 meters. So you know, the flow would not be thermally developed until it flows to this location. So apparently, by the end of this tube, the flow does not have opportunity to be developed. So it is thermally developing. So now we know the flow is laminar. It is hydrodynamically developed, thermally developing. Then which correlation should we use? These three correlations are for developing laminar flow. Remember, we computed the Reynolds number. We know it's laminar. And we know it's thermally developing. So it is developing flow. So which correlation should we use? Yes, we should use this correlation because it is hydrodynamically developed and thermally developing. This Prandtl number should also be evaluated at 30 degrees Celsius. We have computed Reynolds number, D and L are known. So plug in numbers, we can find Nusselt number. What's the relation between Nusselt number and convection coefficient H? We know Nusselt is HD over K. So H is K over D multiplied by Nusselt number. And this K, we know this K should be of the liquid. So this is the thermal conductivity of the glycerin. We can find its value from the same table, and it should be evaluated at the bulk mean temperature. So now we have the convection coefficient. We can find Ts from this equation. Now everything is known. We have already solved for H. We know As is pi dl. M is known. Cp is from the table. Ti and T are known. So you can find TS.